Welcome back, class. My name is Dr. April Ström, and in this video, what I really want to do is focus on concavity. Now, I'm certain by this point you have heard phrases like increasing at an increasing rate or decreasing at an increasing rate. But the question is, do you really know what those are describing and what they mean? So what we really value in this calculus course is trying to attend to the meaning of certain things and not just using phrases because the graph looks a certain way without obviously knowing what is really happening here. So I have 4 examples of some graphs up here for you that I want to talk through about what's going on relative to increasing and decreasing. What amounts are they increasing, decreasing? Are there any rates of change that are increasing, decreasing? So that's the flow. So take this first graph here. I want you to think about, okay, if we were to categorize it as increasing or decreasing, which one would we categorize it as? Well, here we can see as the Y values are actually increasing relative to the increases in the X values. And since the Y values are increasing as X increases to infinity, we would categorize this graph as increasing. I'm going to come back to this here though in a moment. Graph 2, however, as X increases to infinity, my Y values are actually decreasing, thus we would categorize this graph as a decreasing function. Graph 3 that I have here, also if I think about as X increases to infinity, it turns out the Y values are also increasing. So we would call this an increasing function. My last graph here, number 4, again, if I think about as X increases to infinity, what happens is my Y values are decreasing. So we have a decreasing graph. So to recap, we have an increasing graph or increasing function, decreasing function. Here I have an increasing function and another decreasing function. Now that's not a calculus idea. You have seen and heard and explored those ideas in college algebra and pre-calculus before you arrived in Calc 1. But it's really important to make sure that you're aware of what we're describing when we say that the function is increasing or decreasing. But now in calculus, we layer on a new thing. We're going to call it amounts. The question is, all right, so if the function is increasing, how is it increasing? Is it increasing by increasing amounts? Is it increasing by decreasing amounts? Or possibly increasing by constant amounts? So we can have some choices there. We gotta really think about amounts of change. Now you notice I'm really leveraging the word amounts, not rate yet. I'll get there. But right now, amounts of change. So going back to graph number 1, when we describe this function as increasing, we also now want to layer on by how much is the thing increasing, the Y values increasing. Are they, again, increasing amounts or decreasing amounts or constant amounts? So what we need to do is really imagine in our brains as X increases by some amount, my Y values increase by some amount. Let's replicate that. After that analysis in that zone of the graph, let's imagine X increases again by the same amount as the previous increase. But now what's happening to the Y values? Still increasing, but this time the second increase is larger than the initial increase. So as a result, we would say this graph is not only increasing, but it's doing so by increasing amounts. So as we carry on the X, we get larger and larger and larger increases in the Y values, thus increasing by increasing amounts. Now contrast that with graph 2 over here. We said previously that this function was decreasing, but again, the question is it decreasing, the function decreasing, by increasing amounts or decreasing amounts, or perhaps constant amounts? Again, as I imagine flowing left to right on this graph, as X is getting larger, how are those Y values changing? So we know that the Y values are declining here, decreasing, but the question again is how? So as I move through, some amount of X change, I get some vertical Y change here. From here to here causes me to lose some Y values for some given chunk of X. If I replicate that same chunk of X, my Y values lose an amount that's a little less than the previous amount. As my X values increase, I lose less and less and less amounts of the Y. So here, while the Y values are decreasing, it turns out since those amounts of change are getting smaller and smaller and smaller, those amounts of change are also decreasing. So we say this graph, this function is decreasing by decreasing amounts. Let's go to graph 3. Again, we categorize this as an increasing function, but how so? How are the Y values actually increasing? By what amount? Are they increasing amounts, decreasing amounts, or again, constant amounts? As X increases by the same chunk, we always have to imagine the same uniform chunk of X being the increase from left to right. What now is happening to my Y values? Well, as I continue on, my Y values are certainly increasing, but they are doing so by smaller and smaller and smaller increases. Again, the Y values are still increasing, but the way in which they are increasing are by smaller and smaller and smaller increases. So while we would categorize this function as increasing, we would say this function is increasing by decreasing amounts. All right, graph 4. Over here, once again, we categorize this function as decreasing. Again, as X increases, the Y values were decreasing, but how are those Y values decreasing? So if we imagine, once again, vertical changes happening for uniform chunks of X, I have some amount of X over here that decreased, but not too much. As I continue on further, as X goes to infinity, those amounts of change get larger and larger and larger and larger as I go on. So as a result, while we would categorize this function as decreasing, it is doing so by increasing amounts. So we have a decreasing by increasing amounts type of function. So you can see for all of these different scenarios, some are increasing, some are decreasing for the function values, but then we want to know how are those amounts actually increasing or decreasing. Now, what I started the video with is, I know you've heard of things like increasing at an increasing rate, and I haven't said anything about rate yet. I've only explored amounts of change. Now let's layer on the idea of rate of change. That's really what we want to describe in our graphs. So back to graph 1. This graph, again, increasing function, certainly. But now when we think about rate, not amounts of change, but a rate of change, I would love for you to think about the tangent lines across this entire function. So put a point somewhere on your graph, say about right here. And let's draw a little tangent line touching the graph right at that point. And now let's draw a couple more, just so we can see. How about one right about here, and maybe one way up here? Remember, a tangent line is going to touch your function in just one place. Now, I have these little dashed lines to kind of represent the tangent line that's not really there, but it's sort of like this metric, if you will, this measuring stick. We want to know how steep is the function at these zones, at these spots on the graph. And so we can think about rate of change as a derivative. The derivative is our instantaneous rate of change, aka the slope of our tangent line at a given point. So let's imagine this point right here. If you can think of what could possibly be a value that would describe the slope of that tangent line at that point for that graph. Well, we don't quite know the value. We don't have a scale or a function here to measure, but we definitely know that value is positive. Now we move over here and we see, well, that tangent line got a little steeper, still positive, however. And then over here, that tangent line also, its slope increased again, still positive. So what we would describe here in terms of the rate of change is certainly that the rate of change is positive. And as I move through this graph, that rate of change is getting larger and larger and larger. it's increasing in value. The tangent line itself and its slope is increasing in value. So we would categorize this entire graph now as increasing at an increasing rate. The rate describes what's happening to the actual derivative. The derivative is increasing, aka the slope of the tangent line is increasing as I move through. Therefore, we can say increasing rate there. So here in terms of concavity, this is why we categorize graphs of this nature as increasing, but at an increasing rate. Now, over here with graph 2, back to this one. Remember, we said this function was decreasing, and it was doing so by decreasing amounts, like those vertical amounts of change were getting smaller. But now I want to think about the rate of change. I'll use a similar idea. Let's drop in a few little points along the way of this graph and draw in a few tangent lines. Now here, it turns out when I try to think about the rate of change at this spot right here, well, I just certainly don't know what its slope actually is, but I do know with certainty that the slope has to be negative. And then when I move to, let's say, this spot on the graph, I recognize that once again, the slope of the tangent line, aka the derivative, is still negative. But check this out. Isn't this slope a little less negative than this slope? Or another way of saying that is this slope is a little closer to 0 in terms of its value than this slope over here. Lastly, take this spot right here. Once again, I don't know what the actual value of the slope of the tangent line is at that point, but I do know still the slope of the tangent line is negative yet. However, it is less negative here in terms of the slope of the tangent line than this slope of the tangent line. And this one is less negative again than the slope of that tangent line. So as I move from left to right, what is happening to all the tangent lines is that they're getting less and less negative. Or another way to phrase that is they are getting closer and closer to 0. So this is, let's say, super negative. I'll just make up a number like negative 100, pretend. Maybe this one is negative 20. Maybe this one here is negative 5. That's the idea of getting less and less and less negative. So to put it all together, we would certainly say this function is decreasing, but at an increasing rate. Now you might be thinking, wait, how is that possible? We're talking about negatives. Well, once again, just to reiterate, it's all about what's happening to the rate, the derivative, the slope of the tangent line as I move towards infinity for x. And here, since the slope of the tangent lines are all getting less and less negative, they are actually in effect increasing, thus increasing rate. So I have a graph that's decreasing at an increasing rate. Now, let's move to this graph over here. We did categorize this graph as also increasing, but again, in terms of the rate, how is the rate actually changing with this particular function? So as I move from left to right for the x, again, the amounts of change were decreasing, getting smaller and smaller, the vertical change, if you will. And if I think about my tangent lines, let's see what happens to them. Let's say we put a little tangent line right here at that point, and maybe another one right here at that point. And how about one right over here? What I know about this slope of the tangent line at that point is it's positive. Now I get over here to this middle point, I still know that the slope of the tangent line is positive, but it's less positive. And now I get over here to this last tangent line, and I know its slope is still positive, but it's less than the previous slope of the tangent line, which is less than the previous slope of the tangent line. So to summarize the trend here, we would say that this function is increasing at a decreasing rate. The rate word describes the slope of the tangent line, the derivative. Lastly, this graph over here. Once again, we described that this graph was a decreasing function. Now the question is, what's up with the rate? What is happening with the derivative as I move from left to right of this graph? So again, let's pick a point. We'll put a little tangent line right there, maybe another one right about here, and how about one way down here? And if we imagine the slope here of that tangent line at that point, well, once again, we would see that that slope would be negative. And here in the middle point, I see also that slope of the tangent line is negative. But it turns out that the slope of the tangent line here is actually more negative than the previous. And the last point of interest right here, its slope of the tangent line is also still negative, but more negative than this slope of the tangent line, which again is more negative than this slope of the tangent line. So we would categorize this particular function as decreasing, but at a decreasing rate. So now you have an idea of how to describe at least what's happening with the rate and the y values of the function. Now let's layer on the idea of concavity. So coming back here, we would describe this graph, which is increasing at an increasing rate, as being concave up. Well, it turns out over here, we also have a graph, but this one was decreasing at an increasing rate. And as a result, it is also concave up. And lastly, it turns out that graphs 3 and 4, while one is increasing in y values, the other decreasing, they're doing so at different rates. And in both situations, we have a decreasing rate, and thus we have concave down for both of those graphs. So concave up graphs here, 1 and 2, concave down graphs, 3 and 4. And it's all about what's happening with the rate, the slope of the tangent line throughout the function itself. So I hope this particular video helped clarify and make sense of the idea of concavity. And if you like the video, please click like and also hit subscribe for more videos in the future.